Welcome all. Thank you for joining Women in AI Toronto Masterclass series. This is our second of the 3 language intelligent masterclasses we have lined up for July to unleash AI's potential. We have one more session coming up next week, so please do remember to sign up for that as well. My name is Nammi Sriharan. I am the city lead for Toronto Women in AI. I'm also the executive coach and founder of iResilient Coach with a commitment to empowering individuals of marginalized background, finding their true potential by overcoming challenges and breaking the barriers to achieve their goals. I'm always happy to connect and support in any way I can. Women in AI is a global network of female experts and professionals in the field of artificial intelligence, working towards gender-inclusive AI that benefits global society with over 10,000 members across 140 countries. Founded in 2020 in Canada, we are presented in 7 cities across Canada with 6,000 followers on LinkedIn. We have organized over 50 successful virtual and in-person events so far. Our mission is to close gender gap in the field by educating the next generation of female leaders in AI and increase female representation and participation in AI. Today's session will be moderated by one of our volunteers, Gina Theivendra. Gina is a Tamil Canadian product manager, a founder and startup operator. She is passionate about using her unique background in tech, early stage startups, and community health to build and invest in products that solve real world problems in the mental health, digital health, femtech, and education space. Currently, she is building a mentorship-based platform called Mimosa that empowers women and non-binary people across the globe to access resource, mentorship, and community support that they need to achieve their personal and professional goals. She also leads product development for data and reporting products at Conventional Health, as well as program management, operation, and APM Connect. Over to you, Gina.
Thank you, Nammi. And thank you everyone for joining. Very excited for everyone to join us today for our Introduction to Text Classification Masterclass. We're really excited to have Dr. Annie Lee, Assistant Professor at University of Toronto, hosting this workshop for us today. Dr. Annie Lee is an Assistant Professor for the Computer Science Department at the University of Toronto. Professor Lee received her PhD from the University of Waterloo in 2014 under the supervision of Andrew K. C. Wong and Daniel Strasuk from the Center of Pattern Intelligence and Machine Intelligence. She has been a visiting researcher at the Fields Institute, invited by Nancy Reed, and CUHK, invited by K.S. Liang and M.H. Wong, as well as a research scientist at Vertical Scope and Strategy AI. We're very excited to host this workshop on Introduction to Text Classification. So this workshop will introduce learners to applications of supervised classification using text. Text is an essential mode of human communication that can be found everywhere, from social networks and forums to financial and medical documents. And this open class will introduce learners to the applications of supervised classification using text, which is called text classification. So we'll introduce practical applications from the real world and walk through a piece of Python code central to the machine learning pipeline. So very exciting stuff, and thank you again for joining us today. Dr. Lee, I'll pass it over to you.
Thank you so much, Gina, for that introduction. So today, let me share screen. Today, I'll be sharing a simple introduction into NLP or analyzing text or data mining, information retrieval with text. So text 101 text classification 101 has become very prevalent, and analyzing text is something that everybody could use and is interested in. So is very relevant. I am sort of assistant professor at U of T, but moving over to Ontario Tech to work on tech for social good, as well as working on low resource languages. So I am recruiting graduate students, ideally PhDs and postdocs, but also more junior graduate students and volunteers. Okay. So in terms of text classification 101, we're going to take a look at feature extraction. How do you go from this unstructured text to something that's vectorized, and then a code walkthrough. But usually I like to get to know the audience a little better. So I guess my question, if you can just give me a thumbs up or thumbs down, and then I'll get an idea of the audience and how fast I should go through the content. So how many people here knows at least, I guess, intermediate coding in Python? Okay, so 2 people, 3. Okay. Oh, awesome. Okay. So intermediate, you know how to, at least if loops, ifs, classes. Okay, so that's good to know. Thank you so much. That's good. So then my next question is, how many people are sort of familiar with some supervised learning frameworks like supervised, unsupervised, semi-supervised reinforcement learning, or you've implemented, you're familiar with it? So everybody knows some sort of, oh, right. Okay. So everybody, yeah, so, okay. Just thumbs up or thumbs down is fine. If you don't know, then I would really appreciate it so that I can slow down for the minority. Okay. All right. So it seems like majority of the people know these concepts, so I can sort of go through them fairly quickly. So text is everywhere. You can see them in the document. In the documents that you see at work, like PDFs and chats, straight up text, your Wikipedia, anything you read on the internet, that's text. Your tweets, your Facebook messages. So it is everywhere. So can we think of some examples where you use texts in either your work organization or in your own life? So not just yes or no answer, but where would you use text in your own life to? Yep, chats, Slack, emails. Yeah, so you can just type the answer now into social media for sure. Books, yes, books, fascinating. Contracts, especially like any legal practices, check databases, searching as in information retrieval, documents, work documents. And, part of the job of a professor too is working with industry. Either we have these industry collaboration grants where we can work with industry on these text problems, or there's also consulting that we do for industry as well. So those are all possibilities. So work documents, communicating on social media, making blogs, they're all the different areas where text comes into your own life. So you can see that it's very relevant. So what is text classification? So most of you know supervised learning, so hopefully this is not new. But I will try to go through it in detail for those who might have raised their hand and not know this from previously. So one of the widely used tasks for natural language processing or text analysis is classification. So a simple business problem is text classification. So you can imagine, if we break down the word text classification, you're taking a piece of text and you're classifying it into a category or a class. So you can imagine you're reading the newspaper, and for those of you who used to have those physical newspapers, and then it will get classified into one of the sections of the newspaper, right? Does it go into food? Does it go into sports? Does it go into politics? And that will be the categories that it gets classified into. Then in terms of supervised machine learning, what supervised machine learning does is it takes some input data along with some labels. So those labels are your classes or your categories. And then using those known input text and labels, they try to predict in the future. So if I have a bunch of articles with their labels, like I have, a bunch of sports articles, bunch of business articles. So we have the input text, input text like here, and also the label. So we have a bunch of known answers. And then we throw it into a model so that we can train the model so that any new pieces of news article or any new text coming in, we know we can assign a new class label to it. So this is a classical supervised task that's set up, but we are putting in the data input, the input as text. Okay, so let me give you some examples to make it concrete in your mind, and so that you can also find more examples that might show up for you at work. So sentiment analysis is the classic example. So imagine you have a piece of movie review, and then that movie review could be positive, negative, or neutral. So for example, that a piece of text that says there's a thin line between likable, old-fashioned fuddy-duddy and the Count of Monte Cristo. It never settles quite on either side. So a little bit of interaction here. So how many people think it's thumbs up if you think it's positive, thumbs down if you think it's negative, or you can just type your answer into chat. So how many people think it's positive? You can just, so some people think it's positive. How many, or negative? How many people think it's negative? Thumbs down. Or how many people think it's neutral? Okay, there's some positives, there's some negatives, there's some neutrals. Yeah, it's hard to say, right? Because there's some aspects of it that's positive and there's some aspects of it that is negative and is, never quite. And you will find when you do this task, depending on your data, there could be a lot of neutrals and just very few positive, like it's not a balanced number of positive and negatives. So the next one is review ratings. So, your Amazon reviews, your Yelp reviews, there's certain amount of stars. So here's an example of a very positive review and a very negative review. So the positive review from Jimmy from San Francisco says, great food, lovely ambiance and decor. I had some dinner a couple of times and the service so far has been terrific. The food is fabulous, and talk about the bathroom is beautifully designed and decorated. Love the efficient unisex stall and share sinks. So overall, 5-star out of 5, very positive review. Versus a negative review down here, from California, pricey, mediocre, expensive and small. Food was good, but the service was poor. And then never understood, and then I think they said, never understood why a server can't wait until we leave to check the tip. And, you can see that, it has a score of 2. So you can see examples here of very negative reviews as well as very positive reviews. And of course, when you're working on data like this, often for recommendation systems, you need to normalize by users because some people are inherently more positive or more negative than others. Okay. Another example is spam filter. So our question is, you have an input email and then text, and then you need to classify between the two classes. You need to decide whether it is spam, which is a bad email that's trying to, or trying to extort money from you, or trying to, get you to buy things, or is it ham? Is it a good email? So here's an example of a spam email from a man who's trying to extort money. So he's saying, I'm in a hospital with some cancer problems. I'm giving my money away because I'm terrified of my second wife, and I don't want her near my money. And then, at some point you say yes, and then they'll probably ask you to send money, so this is a spam email, which is bad. And there's some classical solutions to this. This has been a problem that's been there since the beginning of time. And some more so this example topic classification is the one that I presented, which is you have a news article, and then you need to decide, which section does it fall under: business, sports, entertainment, politics, so just based on maybe like a title, it's going to get worse. Business brace for cold weather closure of patios. Where in the heat of the summer, Charles Kaboo is already thinking about the chill ahead. So, is this entertainment? Is this business? Where does it fall under? Which category, which category of the classification task does this fall under? More recent, fake news detection. So the input is the article heading and article title and article body. And then they had to decide whether is this fake or is it real. And the idea here is that, we have an example here, Pope endorses Trump, game changer, ending the Fed.com, and then Pope Francis Shockwer endorsed Donald Trump for president, release statement. And then, it's a fake news article, but it looks very legitimate, North Carolina for Donald Trump. So how does text classification work? So let's just reiterate again. We've gone through a couple examples, and we know that the input is in the form of a piece of text. That text could be one sentence, like a tweet, or it could be a paragraph, like a full paragraph, or an entire document. So that's much more context, much more text. And we have our output label. So what class does it fall under? Is it a binary label, right? Like positive, negative, spam or not spam? Or is it multiple categories, more than two classes, like positive, negative, neutral, 1 star, 2 star, 3 star, 4 star, 5 star, or a bunch of topics. And at the same time, there's also these multi-label problems where one single text or one single input instance can fall under multiple categories. So maybe that particular article we saw, it could simultaneously fall under in the news article, it can simultaneously fall under business as well as entertainment or well-being. So there's many different ways of doing that. Okay, so let's open the hood and take a look a little bit at the algorithm underneath. So again, we have our input, output, and the classification model. Supervised learning is divided into training based on data that you've seen, and then testing based on new data that you've never seen before. So in training, we have our input text and we have our input class label. So it's sort of like when you're studying for a test, the teacher gives you the answer with a solution. So you just memorize the solution. So that's what the supervised learning portion is. So you have your input and your label. But as you know, text is just a bunch of unstructured data on a page. It's not set up in a database where you have columns of features and numbers. That's very structured. So what we do is we use feature extraction. So this is a feature extractor step, which takes the text and then extract it into a vector, a feature vector. So that's like vectorization, if you think of things like the Vector Institute. So from there, then you plug it into a machine learning algorithm, which learns this classification model down here. So the training step, you're taking your answers, you're extracting features from the unstructured to structured input, and then you use the algorithm to learn this model. So now you study the tests and the answers, and you know the solution. What you want to do is you want to take the new input that you've never seen before and predict the label. So if I were to give you a new movie review that you have never seen before, then it will take that movie review, throw it through the same feature extractor to vectorize it so that it outputs the same type of numerical vectorized features, throw it into a model, and then splits out a label. So new input, and then let's see, that you've never seen before, throw it into the model, look at the label. Another way to look at this pipeline is you can take a look at the text processing pipeline. Usually in text, if we were to look deeply, there's a lot of different linguistics and NLP pre-processing techniques. So things like tokenization, chunking, out of vocab words. What do we do with misspellings or abbreviations? Any type of padding that's needed of your sentence. Part of speech tagging, positioning of the text, phrasing, and surface forms. You know, those are all classical linguistics and NLP. Some of these are NLP pipeline techniques. Some of them are classical linguistic techniques, but you know, these are the pre-processing. Then for extracting the feature, right? So vectorizing, taking the words in the document, which are now tokenized. So tokenized means words, changing them into a numerical vector at the end. So taking a bunch of words, you know, in a sequence, throwing into a vector. We have a feature extractor. Usually what this involves is one, a bag of words, or taking it into a word embedding, or using a language model. And nowadays we really take a look at large language models quite a bit. All right, so once we have vectorized these, then we can throw it into some sort of a machine learning task. So like a sequence labeling, like predicting positive, negative, or predict classification. Another task that's very common in machine learning is sequence labeling, which is like, you know, part of speech tagging, name entity recognition, where you label each word in the sequence. And other popular tasks these days are, you know, text generation, which is what ChatGPT does, and a lot of it's a task that's becoming more and more accessible to us using encoder decoder, transformer, self-attention frameworks. So the machine learning workflow, if you have heard of it, and this is a course that we offer as a continuing education course, machine learning certificate at York University, is first we explore the data. So for text, you will clean it, explore it, visualize, you know, your labels, and really try to understand the problem at hand. Then you can do some feature engineering. You know, before the deep learning days, this used to be very important. But these days, it seems like you just throw it into some sort of deep learner and it just automatically generate uninterpretable, interpretable features. Then we do some modeling, and then we evaluate those models, making sure that, you know, they're statistically significant. Oh, where did that go? And then, you know, you would iterate on this, and that there's ensemble learning. So how many steps here you have heard of before? So you can just type it into the chat. Which of these steps have you heard before here? Oh, sorry about that. So which of these steps have you heard of before? Most of, awesome. Okay, so I think some of it, okay, so for most of you, this could be probably too simple. Okay, all right, so let's move on. Yes, so thumbs up if you guys want to look at code. I guess thumbs up if you guys want to learn about large language generative language models, and thumbs down if you want to look at code, so that I can get an idea of how to it's like a choose your own. Yeah, so if you want to look at code, then give me a thumbs down. If you want to look at large generative language models, then okay. Not many votes, but let's move on. So yes, we can always come back. But now these days, people really think about, I guess, let me scroll to the code in 3 seconds, and then we'll move on to massive language model. So this is code that's taken offline, online, which you can find easily. But with this text classification, we talk about the type of vectorization features we could use. So you can use, bag of words features, which then you take the words and make it into a set of features. You can do bag of n-grams, TF-IDF. So this is a simple code that you can step through and goes through each of these steps. So this is sort of for self-learning for anyone that's interested. Let's continue onwards. So once how do we tie from this vectorization, from this vectorization, where are we going to do right? Yeah, you still need the baselines. So where do we go from text classification and vectorization into large language models? Oh, sorry. So in terms of vectorization, we're converting text to numbers, and those numbers could be words in a dictionary. There could be embeddings where you cannot interpret. There could be language model outputs, which are just a bunch of numbers. So unlike humans, computers understand numbers rather than words and phrases. And so they need that vectorized matrices and vectors of numbers so that the computer can code it up, use linear algebra, matrix transformation, statistical methods to make it work. Sometimes we use like straight up vectorization, but there's also, sometimes people actually design features, right? So some tasks are very feature dependent, because if you're doing sentiment analysis, then you will be looking at positive and negative sentimental words like adjectives. But if you're looking at topic classification for news articles, then you might look at certain noun words like business, where in sports you talk about football, soccer, basketball. One of the works from one of the profs is classifying and identifying Alzheimer's and dementia. So that's looking at people's speech and seeing, are they saying it out because they're not able to think of words to use, or are they using a lot of repeated simple short words, So that's why features could still be important, even though in today's deep learning days, you might just take all the data and throw it into a deep learning model. So here's an example of vectorization. In the old days. Oh, sorry, my mouse keeps playing tricks on me. My apologies for that. Sorry about that. So we have this movie review. I love this movie. It's sweet, but with satirical humor. The dialogue is great, but the adventure scenes are fun. So this is what we did in the code. We take the words, throw it into a bag of words, and then you see we shake it all up, right? Now there's no more association between the words. And then we just count it in the bag of words. And that becomes a very large dictionary with a very huge vector that's very sparse. So this is, how we used to do things as close to as 15 years ago, before the deep learning age. Now, you can see that we started off with these bag of words n-gram models in just after the war. And then we move on into bag of words and distributional hypothesis, which I think actually became popular much later with word2vect, but I guess it was popular in the 50s. Then we have these probabilistic language models, which is just taking words and counting them and calculating the statistics of seeing what could come next. Then we have more distributional representation, which became the dawn of word embeddings. Your word2vect, your glove embeddings. Really, in 2013, the whole landscape changed. And now we have these massive pre-trained language models, which we call LLMs and large language models. So there's this idea that bigger the better. So there's a scaling law of large language models by a paper from OpenAI. And basically what they say is that, you might have known the scaling laws of chips, like we're sort of doubling the chip speed every on a log scale. Well, same thing with language models. We're doubling so this is on the log scale rather than, like an actual one-to-one scale. So it's growing exponentially. And you can see every year the model is getting bigger. So this is the billions of parameters. So we start off with 0.1 billion, which is, I guess, 10 million. And then we went up to 1 billion, 10 billion, and now we're at reaching 1,000 billion parameters. So this isn't just expensive to train, right? Like one set of experiment costs billions of dollars, but it also is expensive to test or make an inference. Like if you just want to test one sentence, this is very expensive to run it through like almost 100 billion parameters. Also very bad for the environment to be using all that energy. So yeah, so you can see in terms of so this is the exponential growth on a smaller time scale. So this is now on 1-to-1, 1.7 billion 2020. So over here with Turing NLG, and you can see each of the big tech companies are competing with the other. It's moved all over to the companies, and none of it is really feasible by a research lab or normal human beings. And in terms of hyper training and tuning these things, it's all about having TPUs, GPUs, and like server farms and just optimizing. Okay, so nowadays, large language models as foundational models, what's happening is we have these foundational models that's provided by companies, and I think that ethically and legally there's some concerns around that. And so what happens is you have your data sources, you have your different modes of data, you have your different applications, then you will train it on top of a foundational model. And then once you have this model trained on your data set, then you want to do it on some kind of a downstream task. So this is especially true for large language models, but this is also true for like many of the other tasks. I think in image, the models are smaller, so more accessible, but in language, the models has gotten like really big and outside of the usage that's possible by everyday researchers and even like small size companies. So once you train the model, then you will do downstream tasks that are specific to your data set. So this is the type of, this is where we're moving towards. So in terms of the large language model landscape, we have, a bunch of tasks in red here. So generation, classification. I mentioned classification. There's knowledge answering, translation, dialogue generation. And then there is a bunch of different models available. So I don't know if anything is blocking that for you, but we have OpenAI, obviously, Bloom, Meta, Google, Meta's No Language Left Behind, which is a multilingual model. Blender is out of UIUC with Henji. I guess it's a lot of like dialogue stuff. There's also a couple of for-profit smaller companies like Cohere or Anthropic. Cohere is built out of students from University of Toronto. Anthropic is also big because they're very focused on AI safety. Then we have some data-centric tooling that sort of build on top of that. So then we have, similar to here, we have the task, the data, and then the models that come in between. So again, the task, the models, and the data. Okay. So looking at time, I'll just briefly talk about GPT, not in great depth, or generative pre-trained transformers. So here's an example. I'm introducing you to a group of social science researchers. Please greet the audience. And this is what GPT says. Hello and welcome. I'm ChatGPT. And yeah, so that's the answer from ChatGPT. So GPT has three parts. It has a generative part, it has a pre-trained part, and it has a transformer part. So we'll go through each of these letters one by one. So the transformer part, transformer was created in 2017. So like half a decade old, and it's already, become a huge influence on everything deep learning related. Now, we're no longer looking at the neural network created by Hinton and his team of researchers. We've moved on to transformers and self-attention and attention. And so GPT was first created by OpenAI with millions of parameters. And already then people were like, wow, this is like not possible by research labs. And it sort of went on to 1.5 billion parameters, 175, and sort of on and on. ChatGPT 4, the internal working is not released. So in terms of concept of transformers, very quickly, there's embeddings, like embeddings just means that vectorized numbers. There's a encoder decoder layer. Encoding, you can think of like somebody who's encrypting or encoding a message and decode, and then there's some latent space, and then you decode it into back. Self-attention is how they pay attention to itself and parts of your input. In this case, our input is a sentence. Encoder attends all tokens, decoder attends to preceding tokens, just some so this is sort of like an image of how the attention happens. So you can see these little arrows or these little lines. They're talking about the attention of this encoder, and now decoder only pays attention on the next token. So this is a really nice visualization from Google AI. Okay. Now we talk about the generative pre-train. So pre-train we already talked a little bit about. Is like you have the model, you add more data, and you're training it. So in the generative pre-train part, how does GPT learn? It takes a bunch of corpus, and then it tries to study the corpus by predicting the next word. So all this is thrown into the stack of transformers, and then it does a natural language processing task. So the task we're looking at here is fine-tuning to minimize the error of the understanding task. Anyway, and so from GPT-1 or the original, then we go on to the next GPT where they train on more data, add more transformers, add more parameters, and then try to predict the next word. So pretty much more of the same. Then GPT-3, even more data, still try to predict the same, make that model even bigger. But now they're trying to do this task instead of like supervised learning. Now they're trying to do unsupervised or few shot learning, where you don't have as much training data. So here's an example of a few shot demonstration. So now we're getting into harder, deep machine learning. So first, we translate English to French. So zero shot means I just give you the word cheese and I don't give you anything else. And we ask the model to say, what is the translation of cheese for Maj? So that's zero shot. Is sort of like, I taught you nothing, just give me the answer. I just throw you in the pool, just swim. Few shot learning, well, one shot learning, what happens is I want you to translate from English to French. So I give you an example, sea otter, l'autre de mer. So that's one example. So that's one shot learning. And now I'll give you cheese and I expect you to do the task. So that I give you one example, now try to replicate it. So ChatGPT is very good. That's where the whole entire area of prompt engineering, prompt tuning, right? It's one shot. Give it an example, give it a few examples and see if it can prompt it to do what you want. So in a few shot, you'll give it a few example, right? Sea otter, peppermint, plush giraffe. Oh, I don't know. And then now you want to prompt. So this is few shot learning or few shot prompting. So beyond ChatGPT, ChatGPT-4, there's Codex, which is, and I think Microsoft also has code. Is it Codify? No, code, like code generation, which helps you write code. Instruct GPT is fine-tuned on human and reinforcement feedback. So your prompt, explain moon landing to 6-year-old in a few sentences. GPT says, explain the theory of gravity to a 6-year-old, but Instruct GPT said, people went to the moon and they took pictures of what they saw and sent back. So it's much more, it follows the instruction. And yeah, so we can say that it has the new GPT has reinforcement learning, but with human feedback added. And it is pretty much a black box because they're not telling us what's going inside. And all we know about GPT-4 is bigger model, more data, more human feedback, and that, every day there's new things we discover it can do. It can, pass the LSAT, pass the GRE, so, with the dawn of artificial intelligence, are they able to do intelligent tasks? Are they conscious? These are all discussions and arguments. I was just at the conference of computational linguistics association for computer, and really like Jeffrey Hinton gave a speech that arguing maybe AI is intelligence, and some of the community, are really arguing in terms of like language understanding. Is it truly intelligent? So still evolving, but they're demonstrating impressive abilities. Okay. And so here's a image task, and here's some other potential tasks. And the new, I guess, hottest research area is about prompting. Is prompting all you need? There's an entire prompt engineering that's popped up in the past year. Lots of papers being published. And then there's, AI safety considerations, which I think is really important, right? Like, is there unpredictability? Well, would it always give the same answer? How about smaller scale models, and is it always the architecture with the size? Also, I mentioned the brief problem that we have that foundational models that are generated by a few companies. Do they care about ethics? Do they care about bias and fairness? If we're all pushing through this data, there's been talk about is there hate speech, or is there racism, or is there certain things encoded in the data that wasn't accounted for? What if we're all using the same model and it's just shifting society toward certain negative impacts or negative perspectives, because it's sort of like just taking all society into this foundational model and shift it in a certain direction. Other risks include, hallucinations. We all know that ChatGPT can make up things and sound super confident. So, it will talk about untrue stuff. There's toxic and harmful content. There's biased content. There's misleading fake news. And then there's influencers and propaganda that's at play. There's also, proliferations of weaponizing these searches, privacy issues, cybersecurity issues, so risky immersion abilities, economic impact, and sort of over-reliance by all of us in general. So this is the general sort of a big overview of going from text classification, which is a very classical task, and then to all the way to language model and how that fit within the text classification structure. So yes, that's all I have for today. So I'll hand it back to the moderator.
Thank you, Dr. Lee. This was an amazing presentation, and I see we have a couple of questions in the chat, so folks are super engaged. I'll start with this first one from Saranya, who said, should we do feature selection? If yes, what techniques should we do?
I think I mentioned it afterwards that you could tune it specifically to, in terms of feature engineering in industry, usually you can select it based on your task and what makes the most sense for your task. Usually today, people just throw it blindly into deep learning. It's not interpretable, or it might not make sense. but traditionally, there's some engineering involved. And so if you're not just publishing paper and creating new architectures or just trying to beat the state of the art, I think for industry, usually a little bit of engineering and selection could help.
Awesome. And we have another question from Serenia. If we are dumping to LLM, should we still need baselines?
Your LLM could be your baseline to start.
We have another question. Just curious, how do they hypertune this many parameters?
Yeah, so they have their resources, their server farms, their their TPUs. There's, I guess, Berkeley as well. Some professors from Canada, they're trying to, and also at University of Toronto, they're trying to create chips that are specialized to tune neural networks, just optimize the tensor calculations.
Amazing. And Preet asks, how can we stay up to date with industry advancements in large language models? Any recommended resources to read from?
Some of my colleagues follow people on Twitter. I'm not on Twitter, but I think I should. But yes, lots of noise on Twitter. So just, I think just following the right people on Twitter.
Definitely. I think there's probably some LinkedIn influencers too. Women in AI probably repost a couple of those. I think we do some master classes, shameless plug, to talk a little bit about trends. So there's that too. Sriharan asked, the current fad is NLP. How should we as AI enthusiasts approach this? Should we keep it diverse from application point of view or focus on one wing, like say Q&A? What is your advice, Professor?
I think it depends on you and your goals. I guess for me it was addressing one challenge and one problem at a time until you became more of an expert. So it really depends on where you are in your stage of learning and life and where you hope to go and what you hope to get out of it. I would suggest having your calling card or your own brand of specialization. Some people are very good at back end or DevOps, and then you would sort of specialize in that. Some people are good at social science problems and data integrity or data governance, then you specialize in that. And then there's also generalists or implementers. So I think it really depends on your personality fit, your strength, and what you wish to accomplish. So this is more like a life question.
Serenia says, thank you, Prof. Advice taken. Amazing. We have two more questions. So Preeti says, I know that there are techniques such as the sliding window technique and splitting the text into smaller segments to process longer documents with more than 4,096 tokens. However, these techniques can sometimes result in the loss of context and coherence. How can we ensure that the summaries of different sections of the text are related and do not seem like a combination of unrelated topics? Additionally, how can we prevent sentences from ending abruptly when splitting the text into smaller segments?
Okay, so this seems like a very long, seems like a very specific challenge that you're facing either in your particular project. So I think there's different solutions that you can try. You can split it up and pad it. These are all very standard machine learning techniques. I think you do need to sort of study each of the solutions and then try to do an error analysis and benchmark and test it. To benchmark and error analysis, you always have to start out with an evaluation set. So make sure you have an evaluation set so that you can figure out where the mistakes are and to just study the problem deeply. I don't think this is something that you can resolve in the next 10 minutes, but it's definitely worthy to sort of sit down and have an hour-long session on. Again, I am a shameless plug again. I am recruiting graduate students, preferably PhD postdocs level. But people who are generally passionate about low resource language models, and NLP. I also do sort of collaborations with industry through different government grant agencies or consult. So, those are two opportunities to work with me.
Amazing. I know we have some of that information in the chat as well as how to contact Dr. Lee. So if folks are interested, definitely feel free to reach out. I think we have two other questions. Is there an alternative to ChatGPT today for generating text content?
There should be, but ChatGPT is the standard that people go by. I mean, GPT as well. GPT works quite well as well.
And Navina asks, I have a question. Does it require a very good amount of training data for training LLM models?
Okay, there are some holes in that question. So I would just say that so for fine-tuning, so for low resource language, for fine-tuning like a translation model on a like massive multilingual large language model, 1 to 5,000 data points is enough. And that's the exciting part, is that many languages are not covered by these language model, which generally just works for English. But even 5,000 sentences in a language can really help these language models in a specific task. So that's the exciting part. There was a paper by Meta at the associate, like the conference I was just at. It's called Small Data, Big Impact. And that's the work I work on, small data for big impact that can sort of reach society in terms of tech for social good. So that's for fine tuning. But if you want to train a model from scratch, you better be OpenAI, right? Or pre-training or adding a new language into a language model. I think that's a harder task that requires more data. And I'll be happy to talk to anyone about low resource language and how to make these language models robust to those.
Amazing. And we have some thank you messages to Dr. Lee. Thank you, Professor, for answering all the questions. So I think folks had a really great time at the session and learned lots. I know I did. I know we're approaching 1:09, so we're reaching the end of this session. Thank you to everyone who joined the session and tuned in and asked such amazing, engaging questions. And big thank you to you, Dr. Lee, for hosting this session and answering everyone's questions.